Hello everyone, today I would like to talk about my geology storyboards, and now we are on igneous. So just like metamorphic rocks, igneous rocks tell us about a history of plate collisions and mountain building and volcanism, some of the most disastrous things to happen on our planet, volcanoes. Just like metamorphic rocks too, this is very conceptual in that we're dealing with a cross-section of the earth and we're going deep, deep, deep underground, about as deep as you can go. We're going to start from the bottom and go up to the top, and this is color-coded. This one is very much color-coded, and you geology teachers know what I'm getting at here with the color green. Usually molten material in pictures like this are orange or red. I want to stick with the composition of what that magma actually is. And, it's rock too. The mantle is made of solid peridotite rock containing a mineral called olivine, which is a nice green color. We've got some black in there, that's fine. But that gives us an idea, so that's where the mantle is, and this is an UltraMafic rock. As we are heating this up, our yellow flames are our heat sources here at our three separate volcanoes, then we are rising up and we're forming an oceanic crust that is mafic in composition. So we are getting basalt lava flows, and we're getting some embedded plutons of gabbro. So these are mafic rocks. We're going from green, we're going to black. We're going to, kind of continue along here, and our composition is still going to change as our subducting oceanic crust is heating up, and there's a lot of complexity here. I could talk for a very long time about that. I'm not going to, but one of the things that's happening is this mafic magma that's being created is mixing to an extent with the overriding plate, which in this case is a continental plate. You know that because it's pink, and pink is our color code for, you probably know, granite, which has a lot of pink minerals in it. So as our felsic material that's melting at depth here is mixing with mafic, we call that magma mixing, and we are going to create an intermediate type of material. This is going to produce in plutons here diorite, and as this volcano erupts, we get a very cool rock called andesite, named for the Andes Mountains, which are at a subduction zone and have this type of volcanism. So we're getting intermediate material. This volcano may also erupt out very explosively a rock called pumice. Okay, further inland, away from the subduction zone and probably not having anything to do with the subduction zone, we can have hot spots that are kind of rogue. They can be very far from any plate boundaries. A classic one is Hawaii, which would be out in the ocean, because that would also deal with basalt. I didn't put it on the storyboard because I don't have a lot of space. I'm dealing with a continental hotspot instead, like Yellowstone National Park is a great example. So we have this pink material, which again is granite, making up the majority of the oceanic crust. As we heat up granite, well, that material is going to rise to the surface. Anything that erupts out of the volcano may be its compositional equivalent, also a felsic or silicic rock called rhyolite. And Yellowstone is indeed covered in a lot of rhyolitic rock. So that gets into a bit of chemistry, but those are our different environments, whether near the surface of the earth or deep, deep, deep underground, and where different kinds of igneous rocks can form. And students have to really piece together a lot in their minds about texture and composition and thinking about where all of these go here with igneous rocks.